Welcome to SUSECON Digital 2020. Thank you for joining us. Our session today is around application delivery basics with SUSE Cloud Application Platform. Let's begin. SUSE application delivery solutions are composed of two key items. On the left, SUSE Container as a Service Platform, which is our Kubernetes distribution, and on the right, SUSE Cloud Application Platform, a Cloud Foundry version based on a Kubernetes native version. The majority of enterprises are still fully on Mode 1, with on-prem data centers and monolithic applications, or virtual machines and n-tier applications. Mode 2 on the far right is where more than 50% of IT managers wish they would be, which is deploying workloads to the public cloud, containerizing applications, and utilizing microservices. What are microservices? In short, a microservice is a way of decomposing your monolithic application into smaller, more manageable chunks in order to facilitate application development and deployment. The traditional way of development has been a single monolithic application with thousands of lines of code, which is overwhelmingly complex. Fixing bugs and implementing new features become a difficult and time-consuming task. To summarize, you would have a very successful business-critical application that has grown into a monstrous monolithic application that very few, if any, developers understand. It is written using obsolete, unproductive technology that makes hiring talented developers difficult. The application is difficult to scale and unreliable. As a result, agile development and delivery of applications is impossible. Monolithic apps move through each lifecycle stage as a whole. The whole cannot complete one stage if there's still a component that is not ready, causing release cycles to be very long. But there's a new way. The new way, instead of building a huge monolithic application, is to break it down into smaller interconnected services or microservices, which allow you to reduce development release times, making each microservice more manageable, allowing you to fix bugs and implement new functionalities in a far more efficient manner. The increased agility achieved with microservices allow you to progress through separately each part of your application. A full application build is not required before deployment. Any application changes, bug fixes, or new functionality can be implemented, tested, and deployed faster. Containers enable your transformation towards microservices model. Lighter weight services are easy to stop and restart, allowing in-place upgrades, where we can quickly build a new container with the updates and we can simply redeploy. No downtime required. The redeployment of your applications can happen anywhere, from bare metal systems to VMs to the private or public cloud. Containers are replacing virtual machines as the primary code packaging model because they're so much easier for developers to use, allowing them to work more freely, much less dependent on IT operations. Imagine that you're an automaker. An automaker can build cars in many different ways to best satisfy their needs. But not every car is built from scratch. Not every car comes out of the factory either. DevOps workflows allows you to make the choice of what works for you, whether it's a custom build of all your applications or using pre-built solutions and everything in between. The choice is yours. SUSE Cloud Application Platform eliminates manual IT configuration and helps accelerate innovation by getting applications to market faster. Developers can serve themselves and get an app in the cloud in minutes instead of weeks, while staying within IT guidelines, and without relying on scarce IT resources to perform manual configurations each step of the way. Streamlining application delivery opens a clear path to increase business agility, led by enterprise development, operations, and DevOps teams. It does it all with Kubernetes, which many organizations already are using. SUSE Cloud Application Platform runs on top of Kubernetes like SUSE Container Service Platform, Amazon EKS, Microsoft AKS, or Google GKE, combining the best from operator and dev worlds. Cloud Application Platform is a platform as a service platform that takes away a lot of the ops hassle devs need to handle. Developers simply push applications from their desktops using the CLI or Web UI. SUSE Cloud Application Platform automatically configures the environment, provides the required dependency, binds required services, and deploys the application as a container, which is then automatically managed and scaled. Reduce complexity and increase IT efficiency with a lean platform for rapid application delivery at scale. SUSE Cloud Application Platform increases efficiency by running lightweight containers, not resource-hungry virtual machines. It consumes a fraction of a memory footprint of other Cloud Foundry distributions while being as fast or faster to recover and scale. Maximize return of investment with industry-leading open source technologies that leverage your existing investments. The platform uses 100% open source technology, including SUSE Linux Enterprise Server, Kubernetes, Cloud Foundry, Stratos UI, which allows you to protect your investment and lower your risk. SUSE Cloud Application Platform was the first Kubernetes native, enterprise-grade Cloud Foundry distribution in the market, leading the way in this space. Now, let's explore SUSE's community involvement. SUSE is a platinum member of the Cloud Foundry Foundation. We have started and led efforts around Cloud Foundry, containerization projects, and Stratos UI. CF containerization allows for the Cloud Foundry runtime to run in containers instead of VMs, utilizing Kubernetes for automation, eliminating the BOSH requirement of all other Cloud Foundry distributions. This also reduces the footprint required for the deployment of Cloud Foundry from 32 gigs of memory to 128 gigs of memory on VMs. Stratos is a web-based single pane of glass dashboard and metrics that allows users and admins to manage apps running in the Cloud Foundry cluster and do cluster management tasks. Additionally, provides a view of underlying Kubernetes infrastructure. Stratos provides a centralized way of managing your cluster and workloads regardless of where they are, enabling to do multi-cloud management across all supported Kubernetes deployment options. Irene enables Cloud Foundry applications natively in Kubernetes by creating a pluggable scheduling mechanism for Cloud Foundry application runtimes. Irene was originated by IBM, but SUSE has contributed greatly to the project, adopting and supporting it since version 1.4 of the product. The beauty of Cloud Foundry lies in its application runtime, which allows your code, written in any programming language or framework, to be deployed with a one-step command that containerizes, deploys, and manages your applications. Your code is automatically identified, and SUSE Cloud Application Platform pulls in language libraries and frameworks via build packs. These are some examples of supported and provided build packs from SUSE Cloud Application Platform. Instead of manually creating your VM, patching those VMs, creating networks, creating database connections, and attaching them to your applications, cloud-native applications accelerate your time to market with a one-step command that automates the deployment of your code. Currently on version 1.5, SUSE Cloud Application Platform provides a policy-driven, fault-tolerant, self-healing platform as a service infrastructure solution utilizing enterprise-grade open-source projects. Whether you deploy Cloud Application Platform on top of SUSE Container as a Service platform or on any of the public cloud providers. There is a pluggable cloud provider deployment that expands from OpenStack to Google to AWS, or like in this case to Microsoft Azure, via the Azure Open Service Broker. In the case of AWS, we have jointly created an automated way to deploy your infrastructure in a highly available manner and deploy SUSE Cloud Application Platform with the use of an AWS Quick Start. Now, let's begin the hands-on labs. Welcome back to SUSECON Digital 2020. Hands-on session application delivery basics with SUSE Cloud Application Platform continues. Now, let's move on to the hands-on labs. The first thing you need to have is a running deployment of SUSE Cloud Application Platform, as well as SUSE Stratos UI. Without those, you will not be able to follow these labs. The first thing you need to do is log in to your SUSE Cloud Application Platform. I am going to go ahead and use a training user that I had prepared. It will authenticate me, add me to the organization SUSECON, and grant me access to my targeted space, space 1. Okay. At this point, what we will do is start the first deployment of your first app. It will be a manual deployment of the application Dora. You can get the application Dora from my GitHub page, which is part of the lab manual for this session. I will go ahead and clone Dora. I will go into the directory for Dora. As you can see, it is a Ruby application. So I'm going to go ahead and deploy. Let me go ahead and show first actually that I have no applications running on my space. At this point, I'm going to go ahead with a cf push command. I'm going to go ahead and deploy the application Dora. As you can see, I have selected the Ruby build pack. I have selected the stack that I'm going to deploy it in, which is a SLES15 system. I have chosen a disk size of 128 megs. I have chosen a memory size of 36 megs, and I have given the random route option at the end in order for me not to clash with any other apps called Dora. Okay, that will just add a unique name identifier for your application. So let's go ahead and deploy it. As you will see, it will start picking up the application. It will verify and match it to the Ruby build pack. It'll say I'll create the container with 128 meg disk quota and 36 megs of RAM, and it'll start analyzing my data, my application as it goes. So let's see what happens here. It'll create the container like I mentioned. It'll start installing all the dependencies and try to start my application. We're waiting for the application to start at this point. And as you will see, it was unsuccessful starting my application Dora. So it gives me a very important tip here. Why don't you use the command line option cf logs Dora recent. So I will go ahead and do that right now. This will basically go into the logs section and fetch what's the latest in it. Very quickly and easily, I can see that my error is related to disk quota. I am exceeding the disk quota I gave it with my application. So let's go ahead and go back to my cf push manual command, and instead of 128 megs, let's just venture a guess and say it will be covered with 512. Let me go ahead and do that. So you can see there's no need to change or anything to the already deployed. It will just basically change my disk quota from the 128 to the 512 megs. It'll go through the same process again. It's gonna be faster because it's already uploaded most of the items that it requires. But once we get to the point of deployment, we will be able to see a successful deployment with a URL that I can just go hit to see my application Dora. So let's see if and when. Here we go. So as you can see, remember that random route I gave it? So it adds to the name Dora of my application. It basically adds two totally random words and puts them together. So this is going to be my route to hit my application. If I actually do curl and that specific URL for my route, I will be able to get back my Dora application saying, "Hi, I am Dora." Okay. So if I go ahead and check my CF apps again, which was empty, you will be able to see that I have one application running, and that is Dora. Okay. If I want to get additional details on my application Dora, I can say cf app Dora, and it will give me additional details on the application Dora. I can also connect via SSH to my application Dora with the command cf ssh Dora. And I am in my container. Okay. We will go ahead and proceed to delete Dora at this point. That was the first application that you deployed manually. Now let's try to build a manifest so that the cf push command is all you need in order for you to deploy your application Dora. Within my directory of where my app resides, I will be able to create a manifest YAML file. That will require basically the same thing we told it manually, but it will be part of a manifest file with the name of the application, the number of instances that I want it to run at all times. This is where scalability comes in. If I want 3 instances running at all times, I can specify 3 here, and if anything happens to any of those pods running the application DORA, it will automatically restart it for me. Kubernetes will do that. I have selected the 36 megs, and since I know that 128 won't cut it, but 512 will, I'll go ahead and add the 512 disk quota, random route, the Ruby build pack, and I need to change this to sleeve 15. Otherwise, it will not find the Ruby build pack, as I don't have the stack for 12 in my particular deployment. At this point, as I mentioned, all that will be required is to issue the command cfpush. Cfpush will do exactly the same process that it followed the previous time with the manual deployment, only this time I didn't need to give that very long one-line command in order for me to be able to deploy the application DORA. As you can see, it goes through the same steps, matches the build pack to my application, inspects the code of my application, starts building the container that I chose for it to be deployed on, and then it's going to try to start the application and spit out that route with the URL that I can hit again. At this point, my application DORA has been deployed with the following URL, which is different than the last time. Again, the random route working at its best. So if I curl, I should be able to see once again the wonderful I am DORA message. I mentioned the one instance in my manifest file, but if you already have an application running, there's no need to deploy it again with cfpush. If you want your application to scale, you can simply use the command cfscale DORA -i, for instance, and let's say 2. Remember up here it was showing that I was running only one of one instances. So that has scaled, and if I check, let's see, if I curl this with an ID, it should be able to tell me that it's going to 2 different places. So you can see I have either, and this is not very clear, but I will try to highlight it here. There are 2 matching pods that end with 5B16, and the other pod is 3095. So there you can see it. The other way you can see it, if it actually scaled for you, is running the cf apps command, and you will be able to see the number of instances that I have running of DORA now is 2. At this point, I will go ahead and delete DORA once again. This will kill both of my instances running, and I can go ahead and follow for the second app, which is the next step on our guide. At this point, we're gonna go ahead and clone from that same GitHub, git clone, only the name of the application is CF Sinatra. I'm gonna go into the directory. And I am gonna push it manually like we did Dora as well. So let me go ahead and paste the command. Again, cf push the application frank, 64 megs of RAM, 512 of disk. And let's see what happens. Again, it's gonna go through the deployment. Match it up to the Ruby build pack. Inspect my code. And deploy the application frank. Again, Kubernetes is doing all the magic behind in terms of building the pipes, interconnecting the required services. If you have a database, it'll connect it to the database. All of that is handled by Kubernetes. Cloud Foundry basically just runs the application. And there you have it. So this one is another one I can curl. And you will be able to see my app for Frank. Okay. In a similar fashion as we did before, I'm gonna go ahead and scale Frank from a single instance to 2 instances. Or 3 actually. Let me go ahead and scale Frank to 3 instances. Okay. If I go back to CF apps, it should show 3 instances running. Okay. I can add additional plugins and repos, which is the next step on our hands-on lab. Let's go ahead and add a Cloud Foundry community repo with the command shown here. That name already exists, so I'm just gonna put a 1 in front of it, and that has been added to my Cloud Application Platform deployment. At this point, we're gonna try to show statistics for my plugin. So let me go ahead and install those statistics, and then let me pull the statistics for my app Frank. Here you will be able to notice the 3 different instances and the consumption that it has. At this point, we realize that Sinatra does not require 64 megs of RAM as we initially deployed it as. So what we're going to do is we're going to scale down the memory usage to 32 megs of RAM. And that can easily be done with the command cfscale frank -m 32m. As you can see, it did it 3 times because I have 3 running instances. But now my 3 instances are running with 32 megs of RAM instead of the 64 that I initially chose. So it's very dynamic. You can change this on the go, and as you can see, they're very easy to redeploy. So various things that you can do in your own companies. Let's check the statistics again. Yeah, and as you can see, even with 32 megs of memory, my instance 0 is at 66%. So this is much better, more efficient, and it's using the appropriate amount of resources that it requires. All right. Okay. All right, at this point, let me once again delete Frank. CF delete Frank. Yes. To have a clean workspace here. So after deleting the Frank app, I'm gonna go ahead and write an app with Go. So the next step is to write an app in Go. Let's go ahead and create a directory called Go app. And I'm gonna call it hello Go. Okay. Let me go ahead and input my code. I'm gonna create a manifest file. In which I'm gonna give my application a name, a random route, 64 megs of memory, 1 instance is the Go build pack, and I'm gonna call my Go main from my application. All I need to do at this point is run cf push. Again, it'll go through building the container that I've selected the size for. It will go ahead and start inspecting my Golang code. And at this point, it has failed. So let's try to see if cf logs Go app recent shows something that will give us an indication. So let's see here. The error is complaining about the fact that I used Go package and it should be Go package name. So let's go ahead and open my manifest again, and I need to say Go package name is main, and let's try to push it again and see if that will go through and deploy my Go app. I see some warnings, but at this stage is where it had failed before. So as you can see, it's installing the Go language. Building the droplets and waiting for the app to start. So this looks much better than our previous, and there you go. I can now curl this route or URL as it is a public there we go. So let's go ahead and do this one actually. More SUSE. So it shows that I've requested the directory more SUSE, basically. That's the very simple application. Okay. Last but not least, we're gonna go ahead and do a deployment from the Stratos UI. So go ahead and log in with your user. Then go to Applications, click the plus sign at the top of the screen. Then in our case, we're going to choose my GitHub page once again. So let's go to public GitHub. It'll ask you to select your organization and the correct space where you want to deploy your application. I will just specify my project name and it'll automatically populate with the options. So we're going to choose CF Sinatra from the Stratos branch. I'm going to use the latest update. Alright, so I'm going to give my application again the name Frank with a disk quota that I remember I required 512 and memory only 32. I will also select the random route. You can specify stacks and build packs and number of instances here as well. But in my case, I'll just leave it default and it'll automatically know which stack to use, which build pack to use as it goes through my code and matches it up to the appropriate required build pack. So let's go ahead and deploy at this point. What you will see on the screen is exactly what you would see on the CLI. So uploading my code, matching up to the build pack, to the correct build pack, which is a Ruby build pack, as you can see here. It will again build my container. It will create all the connections required. Again, these are very simple apps, but it can be quite complex type of deployment where you have backend databases and things of that nature. So that is definitely a small one here that we have for you today, but definitely you can do very complex things. So again, it's installing the application, and what we will see next is the application starting, and again it should be able to give us a random route that we can hit on our browsers. Okay, so let's wait another couple of seconds for that while the progress report here just states deploying, and once it's done it'll say deployed. So here we go, it has switched to deployed. I can see my URL, I can see that the state is running for my application. So let's go back to the app summary, and again everything I just mentioned is there. My memory quota that I gave it, my disk quota, it has started the app, and for this one just I selected one instance, so it's running one of the one instances. If we come here, it'll automatically go to that route that we created and show us the web page for it. So as you can see, this has been our application, and it has been properly deployed for us. Again, we want to thank you for joining us in SUSECON Digital 2020. We hope you enjoy this new experience. Thank you for watching.